In today's video, we will learn about one of the most important theorem in the distributed system, the CAP theorem. Let's start with what CAP theorem states. It states out of the three properties of distributed system, consistency, availability, and partition tolerance, only two can be achieved at any given time. A distributed system contains multiple nodes that are physically separate but linked together using the network. All the nodes in this system communicate with each other to handle the processes. Now let's understand what each of this property in CAP theorem means. Consistency. It means all the nodes in the distributed system see the same data at the same time, which means if you are performing a read, that is guaranteed to return the most recent write for a given client. Let's understand it with an example. At 10:15, we have a write operation for x with value 10, and then we have another write operation for x at 10:17 with value 20. If anyone is reading data after this timestamp, then they should get the latest value, which is 20. So any client which is trying to get the value of x after 10:17, they should get the latest value. This is what consistency means. Availability. It means a non-failing node will return a reasonable response within a reasonable amount of time. There should be no error or timeout. Let's understand in this system we have three nodes and each of these nodes are working. If any client issues a request to this node, let's say, and this node is in working state, then client should receive a response within reasonable amount of time. Third property, partition tolerance. A partition is a communication break within a distributed system, a lost or temporarily delayed connection between nodes. As we can see, this node got disconnected from the other two nodes, so there is a communication failure here. Partition tolerance means that the distributed system must continue to work despite any number of communication breakdowns between nodes in the system. So which means if a partition occurs, the system continues to work. Networks and parts of networks go down frequently and unexpectedly. Network failures happen to our systems and we don't have any control on when they occur. Given that networks are not completely reliable, we must tolerate partitions in a distributed system. As we cannot avoid these partitions, so according to CAP theorem, this means we are left with two options. Either we choose consistency or we choose availability, which means we can have a system which is consistent and partition tolerant, or we can have a system which is available and partition tolerant. So we get to choose what to do when a partition does occur. Let's consider this example where we have a distributed system for a bank with three ATMs. If there is no network issue, all of them work fine and each ATM sees a consistent view of the data. What if ATM 3 gets disconnected from the system and it loses communication with other two ATMs? In this case, it means it has suffered a partition. Now we have two choices. First choice being choose consistency. In this case, which means each ATM must have consistent view even if there is a partition. In this case, you can only support read queries like balance check, but you cannot accept withdrawal requests. So system is not 100% available as it cannot accept withdrawal requests. Once this partition issue is resolved, you can again start accepting withdrawal requests. Another choice you have is choose availability. In this case, every ATM continues to accept withdrawal requests and you keep track of all the transactions during this period. In this case, data view will not be consistent across all the ATMs because there is a communication failure. Once the partition is resolved based on the transactions during that time, you try to calculate the current state of the system to give the consistent view to all the ATMs. But there are chances that some of the account balances will be negative, which is something we don't want. So in this case, we must go with consistency over availability. So the decision between consistency and availability is a software trade-off. You can choose what to do in the face of a network partition, so the control is in our hands. It depends upon what type of system you are dealing with. So, if we are going with consistency, in that case, we wait for a response from the partition node, which could also result in the timeout error, which means it is not available. The system can also choose to return an error depending on the scenario you desire. So, in the cases like in this bank distributed system, you can choose consistency over availability when your business requirements need atomic reads and writes. If you go with availability, then we can return the most recent version of the data we have, which could be stale, which means it will be inconsistent. In this case, the system state will also accept writes that can be processed later. As we saw in the case of ATM example, you can process all the transaction later when the partition is resolved. You can you can choose availability over consistency when your business requirements allows you to have some flexibility in terms of when the data in the system synchronizes. Availability is also a compelling option when system needs to continue in spite of external errors. So what you choose from consistency and availability totally depends upon what kind of system you are dealing with, what are your business requirements. The CAP theorem does not mean that system can never provide these properties at the same time, but it can guarantee just two of them. Because in distributed system, partitions cannot be avoided. It means in a distributed storage system, you either have to choose consistency or availability, but you cannot choose both. Thanks for watching this video. Hope you have learned something useful.